So you're building in the cloud, right? And you're probably using a virtual private cloud, a VPC, to keep everything nice and secure. But have you ever stopped to wonder if your cloud traffic is as private as you think it is? Today, we're diving deep into VPC Endpoints, a super important tool for really locking down your network and even boosting its performance. Let's get into it. You've done all the right things. You've built your applications inside an Amazon VPC, and you're assuming everything is nicely isolated and totally private. But here's the thing. Is it really? Let's take a closer look, because the answer might just surprise you. So here's the catch. When your application, safely tucked inside your VPC, needs to talk to a core AWS service, say to store a file in S3 or manage an EC2 instance, well, that communication often has to leave your cozy private network. It actually travels over the public internet to get where it's going. And that means, yeah, you're exposing your data to all sorts of potential risks along the way. Okay, but don't worry, there's a fix for this, and it's a tool designed specifically for this problem: the VPC endpoint. Think of it as creating a direct, private connection from your VPC straight to those AWS services, keeping all your important traffic completely off the public internet. So what is a VPC endpoint exactly? At its heart, it's a highly secure, private connection that guarantees when your VPC talks to an AWS service, that conversation, it never leaves the Amazon network at all. It's all internal, all private, all the time. You know, the best way to think about this is like a private highway. Instead of sending your data out onto the public internet with all the traffic jams and, potential hazards, you're giving it its own dedicated, secure express lane that goes straight to its destination. No exits, no off-ramps, just a direct path. Now, to build this private highway, AWS gives us two different tools to get the job done: gateway endpoints and interface endpoints. Now, they both get you to a similar place, but how they work, totally different. So let's break them down. All right, first up, let's talk about interface endpoints. Think of this one as the modern, super flexible all-arounder. It works with a ton of AWS services, which makes it the go-to choice in most cases. So how does this thing actually work? The magic here is something called an Elastic Network Interface, or ENI for short. AWS literally drops a network interface with its very own private IP address directly inside your VPC's subnet. It's kind of like giving that AWS service a local PO box right inside your own neighborhood. Okay, so here's how that actually plays out. When your app tries to call an AWS service, the DNS doesn't point to some public address out on the internet. Nope. Instead, it resolves to the private IP address of that ENI right inside your VPC. All the traffic is then routed internally, where a really cool technology called AWS Private Link creates this secure private tunnel directly to the service you need to reach. And this flexibility is really what makes them so powerful. They support a huge range of services. You secure them using the standard security groups you already know and love, and you can even connect to them from your own on-premises data center. Now, the only catch: this power and flexibility does come with a cost. You're looking at an hourly fee plus some data processing charges. Okay, so that's the modern all-arounder. Now let's talk about the other type, the gateway endpoint. If the interface endpoint is the flexible new kid on the block, you can think of this one as the focused, old-school specialist. And yeah, the way this one works is completely different. There's no ENI, no private IP address inside your VPC. Instead, a gateway endpoint works by tweaking your VPC's route table. It just inserts a special rule that basically says, hey, any traffic trying to get to this service's public IP range, don't send it to the internet, send it to me instead. So what does that look like in practice? Well, you create the endpoint and you tie it to one of your route tables. AWS then injects a new route into that table that points to a special prefix list ID, which is basically just AWS's own managed list of IP addresses for a service like S3. So when your instance sends traffic to S3 or DynamoDB, that route table intercepts it and shunts it through the private gateway. Pretty clever. And this is where you really see their specialist nature come out. Gateway endpoints only work for two services, S3 and DynamoDB. That's it. You also control access using a special endpoint policy, not security groups. And because they're just route table magic, you can't access them from outside the VPC. But here's the big trade-off for all those limitations, and it's a huge one. They are completely free, no charge. Okay, let's put it all together. How do you actually choose between these two? Well, it really boils down to a few simple questions. Do you need to connect to anything other than S3 or DynamoDB? Then you gotta use an interface endpoint. Do you need to get access from your on-premises network? Again, it has to be an interface endpoint. But if you're only connecting to S3 or DynamoDB from inside your VPC and you want to save some money, the free gateway endpoint is the perfect tool for the job. All right, so we've gotten into the weeds on the how, but let's zoom out a bit. Why does any of this actually matter? What are the real ultimate benefits here? It really comes down to three huge things. Number one, and this is the big one, security. By using a VPC endpoint, you are completely removing the public internet from the equation. Your critical, sensitive data is just never exposed to risks like data sniffing or man-in-the-middle attacks. It stays safe and sound inside Amazon's network. Then there's performance. The AWS Global Backbone is an incredibly fast, highly optimized network. By staying on that private highway, you get lower latency and way more predictable, stable performance for your applications compared to taking a trip across the public internet. And finally, number three, something your finance team is absolutely gonna love, saving money. See, if you have instances in a private subnet that need to reach AWS services, you might be paying for a NAT gateway to let them out. Well, using an interface endpoint can often get rid of the need for that NAT gateway entirely, which can save you a ton of cash on data processing fees. So really, when you step back and look at the whole picture, the value is crystal clear. You get better security, which helps with compliance, you get improved performance, and you get potential cost savings. You're not just picking a piece of tech, you're making a strategic choice for a better architecture. It's a win-win-win. And that brings us to the big question for you. I want you to think about your own cloud setup right now. Where is traffic leaving your VPC that really doesn't have to? Where can you plug in a VPC endpoint to make things more secure, faster, and cheaper? That's definitely something worth thinking about. Thanks for joining me.